In this lesson, we'll look at DHCP's role, how to configure DHCP, and the process it goes through to assign IP information to a client. Every device on a network requires certain configurations so it can communicate properly. At a minimum, each device must have a unique IP address, subnet mask, and default gateway. The device might also need a specific domain name system or DNS assignment and maybe some Windows naming service or WINS server information. This all depends on the specific network you use. If you only have a few systems, it's not very hard to configure these options manually. The problem is, if you have to manage a large network, manually configuring each device just isn't practical. That's where DHCP comes in. When a device connects to a network, a DHCP server sends information to the device so it can communicate. But before this can happen, you have to configure the DHCP server. Let's look at that process. For DHCP to work properly, you must first configure what's called the DHCP Scope. This defines the network IP configuration that will be sent to your devices. Depending on your network, you might have different devices that act as your DHCP servers. For example, in a small office or home, you might just use your wireless router. But in an enterprise environment, you typically use a Windows or Linux server to handle this. The process to configure Scope depends on your DHCP server, but the Scope options we'll go over will be the same in almost any situation. The first Scope item to configure is the IP address range and subnet mask. This isn't just defining which addresses can be assigned. This is where you also define which addresses are considered valid for your network. When you specify the range, you can simply include all valid IP addresses, or you can limit the number of addresses as you see fit. For example, if you have a Class C private network, you can add all 254 host IP addresses, or you can specify that only the IP addresses 192.168.5.50 through 192.168.5.100 can be assigned. This is one way to limit the number of potential network connections. Next, you need to specify your exclusion or reservation addresses. These are the addresses that you don't want your DHCP to assign. You typically use these for servers, printers, routers, or other network devices that could cause problems if the IP address changes. While using exclusions or reservations has the same result as not assigning specific IP addresses, you go about assigning them in different ways. Excluding an IP address range simply blocks those addresses from being assigned. To use those addresses, you need to manually assign them on each device. Reservations make this easier by reserving an IP address to a specific device by using its MAC address. Whenever that device connects to the network, the DHCP server knows to assign it the defined information. When you assign a device an address through DHCP, you need to define how long that address can be used by that device. This is called the lease time. While a lease is active, that IP address can't be reassigned even if the device disconnects from the network. When the lease is halfway over, the device attempts to renew the lease if it's still connected to the network. You can set the lease to last for days or just a few hours. If the devices on the network are likely to stay connected for the most part, you should probably set the lease to last for a few days. But if clients want to connect to a guest network and are coming and going, set the lease for a short time so available addresses aren't tied up. The last items to configure in the scope are the default gateway and any DNS servers you might need to specify. If the network is still using WINS, you'll need to define that as well. Once you've configured the scope, it needs to be activated before it can start assigning IP information to your devices. When a new device connects to your network, it goes through a 4-step process to obtain the IP configuration from the DHCP server. The first step is DHCP Discover, where the device sends out a DHCP request on the broadcast address looking for any DHCP servers. The DHCP server gets the request and responds with a DHCP offer packet. This packet contains the DHCP server's information. The client then sends a DHCP request packet to the server. The final step is the server sending a DHCP ACK packet or DHCP Acknowledge packet. This assigns the client's IP configuration and allows the client to start communicating on the network. When the device's lease time is halfway up, the renewal process takes place. This process skips the discover and offer steps. The client sends the DHCP request packet to the server, which responds with the DHCP ACK packet and renews the IP configuration.